All right, we are now live. Hello, good afternoon to everyone joining us from the Gulf, and a very good morning and good evening to our international audience joining us from outside the Gulf for the very first RIBA international event to kickstart 2021. Before we begin, I wish you all a very happy and healthy new year. I'm Mithuna Murugesh, the RIBA Business Development Manager for the Gulf. As most of you know, the RIBA in the Gulf covers 7 countries in the region, including the UAE, Qatar, Saudi Arabia, Bahrain, Oman, Kuwait, and Jordan. And we are pleased to have members joining in from all 7 countries today. We also have an international audience today. I know we have people joining us right now from the UK, India, Australia, Malaysia, Ecuador, Greece, and Singapore, to name just a few. So as we kickstart 2021, it's my pleasure to announce the launch of a new event series, the RIBA Gulf Live Lunch Talks, which will be a series of virtual sessions like today that are designed to share and expand knowledge on projects and ideas from across the Gulf and promote interactive conversations with leading architects to the Gulf and international audience. This series will run digitally throughout the year for your easy access. Before we begin, actually, if you would like to join the RIBA to keep up to date with upcoming RIBA events and participate in them, please do send in your email address in the chat bar alongside, and the team will be able to support you personally. Similarly, if you have any thoughts or any questions for our speaker today, please send them in at any point of time during the session in the chat bar alongside. Now, moving to today's inaugural session, it's with great pleasure that I introduce Dr. Georges Kachaamy, the Director of the Center for Research, Innovation and Design at the School of Architecture, Art and Design, American University in Dubai, who incidentally the RIBA signed a Memorandum of Understanding with in December last year to further support architects and students in the region. Dr. Georges Kachaamy will be discussing futuristic architecture that utilizes available advanced technologies to completely liberate itself from the ground and float in air. So thank you, Georges, for joining us today. Over to you.
Hello, everyone. Thank you, Mithuna, for this introduction, and an appreciation goes to RIBA Gulf for providing me this platform to talk about my ongoing research, work, and exhibitions. It is a privilege and an honor to be here today. Please just give me a second to actually share my presentation. So I hope that you can see it. Perfect. Okay, just to give you a brief context about today's topic, it is under the big wide umbrella of future environments. Gravity Defiant Architecture, also known as GDA, is an ongoing research that initiated roughly 6 years ago. This work was itself a continuation of an organic evolution of what I researched at the University of Tokyo in Japan between 2004 and 2008. At that time, the research was about spaces that can influence the well-being of individuals. Before I delve into the presentation, I would like to start with a quote about the power of inventing the future rather than predicting it. Many have said it in different ways. I see a big deal of its truthfulness just by observing some of the current inventions that we are experiencing at the moment. Today's talk is organized in 3 main parts. The first one deals with the impact of imagination in the past or present on current and future ideas and realizations. The second part talks about what I refer to as extopias and selected plausible future environments. The final section is about the current state and evolution of GDA as one of these innovations. It is important to add here that some of the materials used in this presentation falls under a fair use of others' work to illustrate a specific point for research, scholarship, and educational purposes. I do not claim some of these contents to be my creation. I do not promote the mentioned products or companies, nor they endorse me or my work. Also, the following slides showcases an ongoing research that has been presented in many forums and online seminars. Some of the materials have been used in prior appearances, and they are not unique to this presentation. Now, many of the ideas that have been imagined, debated, and discussed in the past have become a reality that we are currently experiencing. And all we have to do is to just do simple correlation to see its impact. The power of imagination can sometimes modify or even recast the outcome of reality. The beauty of these two worlds, the one in the mind and the one in the physical realm, is that they are in a yin-yang relationship and are in perpetual cycle interacting with each other and ever changing to produce different outcomes. There is no doubt in upholding the statement that the imagination is key to pre-experiencing alternative futures. One of the best examples I can think of are these images that you see on the left that are taken from a sci-fi series which illustrate a city in 300 years from now, while the images on the right are actual images of current state of some of the contemporary cities. In this one is Dubai, but of course it's not the only one. And many examples exist like this. Another correlation that I find to be remarkable is a movie shot of a digital projection of a screen on a building taken from Blade Runner and the shot at Shibuya Crossing in Tokyo, Japan, one in 1982 and the other in 2017. Also, some designs that at a certain period were difficult to be constructed, while others were accomplished and built even though it seemed impossible to do so. And this remarkable project is a materialization by excellence of what 1 century can realize for a design that seemed unlikely and very challenging to construct. One has to admit that imagination, as subtle as it is a powerful tool that can mold the physicality of the future. So on the pendulum that oscillates between a utopian or dystopian future of cities, one has to admit that we might end up with a multi-directional outcome of plausible futures rather than one singular and a uniquely directional one. The X factor that relates to inventions and the plausible state of our environment will play a big role in deciding the direction and these outcomes. With regards to inventions, there are quite abundant, and there is no doubt that some will affect and impact our future. But with the time we have for this presentation, it is not possible to go through all of them, not to mention, the ones that are still under research, and in process. Therefore, the hereinafter selected ones are not the only and can be a stepping stone to even different environments. Towards city of digital and sense illusory environments, holotopia is when our physical reality is augmented with the usage of a 2D screen that provides information overlapping a 3D environments or a 3D asset that are mapped onto a 3D physical world. This is, augmented reality versus mixed reality. Examples such as Magic Leap and HoloLens are but a few, and of course, more are on the way. Vtopia, of course, towards cities of dreams, imaginations, and fantasies. Here, the sky is the beginning and limitations exceeds the one in our minds. And I'm not only talking about the creation of a virtual world where you can navigate, but one that can have the virtual capacity and behaviors, where space can be multiplied and the law of nature can be transcended, such as being in different spaces at the same time and so forth. Utopia, towards cities of artificial intelligence, robots, and autonomous vehicle machines. If we go back just 30 years ago, many of these scenarios were scenes from sci-fi movies. I'm from a generation of cassette and floppy disks. So these topics were part of fantasy movies, such as, The Lawnmower Man, if you ever watched it. You see, technology is a moving target. And with every advancement, there is an impact on society, and of course, on our environment. What is fascinating now is that many examples are present around the world that we can experience live. Here are but few that we can see, and some are planned to happen in the near future that you can see here on the right. It is called Woven City. Of course, the pandemic made these more visible to us, but they were already in the making. You can check out the automated supermarkets or cafes, and they all will have a significant impact on our lives and the way we use space and visit places. Here in Dubai, for example, you can see that transformation very quickly already happening, such as in Etisalat and Diwa, also in some commercial shops, such as the Robo Cafe in Festival City. With regards to the state of the planet, so no matter how advanced humans think they are, nature will always be the mother of all inventions and inspirations. It is the most omnipresent, omnipotent, and omniscient teacher. And everything we discover has already been there in that same nature. We just have to closely observe and monitor it, so these discoveries are unlocked to us. Accordingly, we have to humble ourselves and admit that there are things we do not yet comprehend very well. However, there is one important change that is backed by empirical data, which the humans are a catalyst of, or even some would confirm that is the reason of. And that is climate change, which poses two behaviors, mitigation and adaptation. In his book, Future Cities, Paul Dobraszczyk explains it perfectly when he mentions the flood scenario and the rising of the sea level caused by the melting ice in the polar region, which will create an apocalyptic dystopian type or not of future event. Of course, the flood idea is not new and goes back in history, whether from myth or legend, they are quite vivid in our collective memory. Specifically in his Unmoored Cities, Paul talks about adaptation rather than just mitigation, and how cities might acclimate to the threat posed by climate change. He mentioned three ways: the drowned, the floating, and the airborne. In his book, he does not mention only these, but also talks about vertical cities and the unmade ones. Therefore, I easily identify the important relation between what he mentioned and the work that I'm conducting, which is, although is not related to mitigation, but rather an adaptation, not only, but rather to an adaptation. And to be more specific, the airborne scenario. So, the question, will architecture rise above it all? This is a challenging question to answer, but definitely is not a new one, as I will demonstrate in the coming slides. And although an airborne structure may seem to some an impossible and unrealistic aspiration, others has argued that, and many individuals have tackled it directly or indirectly. Accordingly, one can concur that if you can levitate a train that weighed 50 tons, why not a house? Like many, I always been fascinated by the celestial bodies, you know, the moon, the sun, the stars, and always wondered how can something that massive be floating like this in our skies? Actually, throughout human history, celestial bodies appearing in the skies, mysterious and weightless, have been always a source of adoration, admiration, aspiration, inspiration, and wonder. Of course, science explained it and tried to demystify this, but it did not deter me from keep wondering about it. I'm not the only one and will not be the last. Many before me and many after me will still be fascinated by that and will still contribute in this ongoing research on how we can defy gravity and liberate ourselves from it. We all know gravity with a capital G is a big word, as it is one of the natural phenomena, and we say the law of gravity because we all have to abide by it. However, throughout human history, we always wanted to defy it in a way or another. When someone mentions levitation or anti-gravity, the first thing that comes to one's mind are H.G. Wells' Cavorite or James Blish' Spin Dizzy. Both novels, First Man in the Moon and Cities in Flight, are indeed inspirational. Other examples like the 1726 Laputa Flying Island, the 1820 Minerva Balloon, and Cloud9 are but few. Of course, other authors, artists, architects, engineers, and even scientists worked and still working around this topic with one singular goal. This is to defy gravity. And since Notre Dame Cathedral of le XXe siècle in 1883 up until the Airlander of 2016, one can clearly see the blurry line that has been smudged even further between the imagined and the realized. And what seems to be an unfathomable idea in a TV series might end up becoming a reality. Other artists, such as Thomas Saraceno, in his famous installation Cloud Cities, and other works, where he actually created accessible spheres and domes suspended in mid-air, have provided a true and new experience of what an aerial space can be and feel like. Also, floating furniture and objects have been designed and executed, and the two examples here are but few. Another influential research is of ARX packs owned by the Hendersons, who are working on magnetic field architecture that reminds us of the Back to the Future movies of hoverboards. Of course, they are doing more than that, but you see the point. Others, such as the Japanese Daishin system and the superconducting magnetic levitation technology, are pushing in that direction as well. All these engineers, artists, authors, and companies are attempting to defy gravity, where each of them has their vision and goals. Some are more practical, others are more symbolic and or theoretical. So now, where architects stand on that? Did they directly or indirectly try to do similar attempts? Here we can clearly observe in many of the landmarks that there is a spirit of structurally challenged gravity, whether through creating a box in the mid-air on small pillars such as Villa Savoie, or on few big posts such as the Edo Tokyo Museum or Tokyo Big Sight. Even the attempt of creating a long cantilever in the case of the K Museum that you see in the middle is but a testament of that attempt. I see one of the most interesting new attempts would be of Norman Foster one by generating an architectural roof that appears like it is floating on its own, of course, by eliminating all pillars, as you can see in the image. Here, the lightweight roof seems floating in the air like a flying saucer. The project on the right is the One Zabil, the link in between two towers, is a bridge with the longest cantilever in the world, according to developer Ithra Dubai. That is still under construction as we speak now. The project on, some of the selected works here have shown buildings that give the illusion of floating structure. But for obvious reasons, they all were connected to the ground in a way or another. Of course, architects' attempts are commendable on many levels, but the next obvious challenge would be to ask, will architecture be able to completely and independently liberate itself from the ground? And if it did so, will it lose its identity? Of course, as Mandela is saying, that it always seems impossible until it is done. And no matter what, technologies may evolve or become redundant, but the dream of flight will always be there. This leads to the current work that I have initiated and the case of GDA. Originally, my work initiated, as I mentioned, at the University of Tokyo. When I was doing my PhD in Japan, I was experimenting on spaces of well-being and researching the impact of architecture on feelings and emotions. Quite a different topic, but what made me evolve in this direction is when I moved to Dubai, I decided to take this research further and add a break through available technologies in order to allow architecture to levitate. The purpose was to totally create a secluded place separated from the city within the city, thus the levitated platform. Some of the outcomes of the research have led to the invitation of showcasing the prototypes, example by the Global Art Affairs Foundation for the exhibition at Palazzo Bembo in the context of the Venice Biennale that was supported by the European Cultural Center and the American University in Dubai. It was apparent to me that throughout its evolution, architecture has crawled out of caves, settled on grounds, surfaced on water, climbed on pilotis, stood tall, and even danced. Now it is about time to challenge itself, defy gravity, and rise up. That was one of the statements in the exhibition. So what would be the benefit of doing so? Some are theoretical, symbolic, and even practical. Here are some, but not limited to the following. Create the first and only iconic architecture in the world that completely separates itself from the ground. Liberate the ground from buildings to generate more greenery and public spaces. Protect architecture from natural disasters such as flood and earthquakes. Set up the platform for futuristic and innovative architectures that will allow for a new human experience among the clouds. Accomplish what was perceived as impossible in a place that knows no limitations. With all the challenges and opportunities in this research thus far, I have used many methods in order to develop this work, and some will still be required to progress further, from generating evidence-based experiment to interdisciplinary fields, finding the adequate support, until the execution of prototypes, the scalability of them, and finally the mean of disseminating the results and outcomes. In general, advancement in any field of study is an ongoing, ever-evolving, and an iterative process exercise. GDA research is not an exception, and although defies gravity, it still abides by the law of time. The main challenge of this research is to generate a totally self-sufficient, independent architecture that liberates itself from the ground and can stay well balanced in the air. Mainly technology, or lack of it, was one of the main factors or obstacle that did not allow the application of such ideas. But now this has changed and is changing as we speak. One of the results of the research has shown that some of the main components for the success and stability of the outcome are threefold: design, technology, and materiality. But they are not the only. In addition to the composition and form, the importance is to understand the equilibrium and the influence of the dead load and its capacity to accommodate the live load within these objects. Obviously, the project must use lightweight materials without losing its structural rigidity and integrity, and strong enough technology that can levitate the weight of the structure and by that architecture. Some concerns were raised that dealt with access to the floating platform or water distribution and so forth. Of course, this has been discussed. Obviously, obstacles are part of any ongoing and process research, and they will be dealt with as they arise. Some of the significant aspects that are much interconnected must be taken into consideration. They are as follows: design. So form, function, and structure are crucial to create self-sufficient architecture with the right aesthetics, composition, and balance in order for it to float and functions in the air. Size. The scale of the project will determine the type of architectures that could be considered for the work. This affects directly the weight that the structure can reach in relation to the strengths of available technology. When I started generating prototypes, it is important for me, I didn't want to go with a symmetrical form, but I wanted to go with an asymmetry. So I started in very small dimension, almost 10 centimeter, 4-inch long, and that weighted only 20 grams. Then with time, I managed to augment the size, scale, and model and prototypes. The latest exhibited prototype was almost 2 meters and 7 feet long and weighted 2,000 grams. But the next one currently in process will be of bigger size and scale, and perhaps also different technology. Technology, which is the second, there are many available and under consideration technologies. I'm not thinking of just one technology. To state few, electromagnetism, superconductivity, and unmanned aerial vehicles that are capable to make the project float in the air, similar to the technology that is being used to levitate a train, or like the one that can levitate unmanned vehicles. The advancement of the technology will provide more strength, and by that the capacity to levitate heavier objects. Also, I have experimented with different technologies for the floating models. The current system make use of electromagnetic, but it's not the only one. The third one is materiality. The search for the adequate materials that can be light enough and at the same time rigid to withhold natural and human pressure. This affects directly the appearance, the weight of the project, and its integrity to structurally stand with minimum architectural elements. So I managed to work with different ones. Now, weight, the dead load of the project, will consider if it can accommodate live load and to what extent. In addition, it will affect directly the plausibility of the structure to float in the air. And this affects directly the hovering height that the structure can reach in relation to the available strengths of the used technology. Now, all the above elements are not the only aspect to consider, but they are the most impactful for the development of the research. Clearly, they are all intertwined and interdependent on each other. I have used different materials as well, starting by paper and cardboard to 3D printing ultralight plastic material, and currently is trying to experiment with carbon fiber as a strong and rigid lightweight material. I have to admit that I feel fortunate and humbled because at an early stage of the work, people were positive about it and actually have motivated me to keep pursuing it. The dissemination took different form, but the focus was always one. And one of the outcomes that took the attention of the public was Rising Oasis series of prototypes. They came out of the GDA, the spring, the river, and the waterfall. These series are prototypes that came out of the research, and of course the research is still producing prototypes, and it's still being on. The aspiration was to not stop at the idea, but to move forward and generate actual prototypes that kept growing in size, weight, and levitation. The exhibition of the spring prototype was in Venice in the context of the Venice Architecture Biennale in 2018. I'll show you a small video of it. The exhibition of the river prototype was in Dubai at Dubai Design Week in 2019. Through this platform, the work was acknowledged by major media outlets such as CNN, NBC, Sky News, and so forth. I'll also show you a small clip of it. Now, due to the current pandemic, it was challenging to do a physical exhibition with real physical prototypes. Therefore, we had to be more creative. So I reverted to a different type of exhibition. Here is the animation of the third prototype before I elaborate on the method that we used. On December 2020, I was invited by Illuser to actually give a virtual talk about architecture and technology. And from there, I have given the opportunity to showcase the waterfall prototype, where the project was actually built virtually, one-to-one, within a virtual city called Illuser. The exhibition is still present now online, where you can experience it using virtual reality headset. You can visit it on Illuser website and check it via the Samsar platform. I'm going to show you just a little bit of what we did so that you get the idea. Some other exhibitions were plausible in pre-COVID time in Dubai and also in Salerno. Here are some close-up on two of the prototypes that were exhibited in Dubai and Venice. Now, the research and the exhibition were disseminated in many media outlets in the form of published articles, conferences, and television interviews. The most enjoyable experience was to see how people interacted with the project and the intriguing and sometimes the difficult questions that were asked to me. Thank you, everyone, for your attentiveness. I hope I did not exceed my allocated time. I'm happy to hear and try to answer your questions. Actually, please feel free to visit of any of my social media presence. I have most of the videos online on my YouTube channel and Instagram and all of that. So thank you. And let me unshare the video.
Great, thank you, Georges, for that wonderful presentation. Very interesting, actually. Perhaps we can move to the interactive session with our audience now. So please do submit your questions or thoughts regarding today's topic in the Q&A bar on the right if you haven't already, and we can run through them. It's best if we give it a minute. I know this lags slightly. I've seen a couple of questions come in, actually. We have someone joining us from Dorset in England. Will the seminar be recorded for playback? Yes, it will be available on the RIBA YouTube channel. We have a question, Georges, for you. So how will it stand cyclones and tornadoes?
Yes, that's actually a very interesting question because, in the design, you have to take into consideration the wind also and all of that. So it could create or it could have specific holes or specific way of allowing the force of wind. But this, of course, will have to be as a study, and you have to, once you create a bigger prototype, to see and study it. But there is a way, like if you have towers, also there is a way that to make the wind not affect very much the structure. I mean, one example, as I said, is to provide more holes in the actual building so that the force of the wind is not as, or even the shape itself can be in a more aerodynamic, so that it's not really affected by the, by the wind force.
Very interesting. Another question has come in. What about the ease of accessibility to the building?
That's actually a very, very good one. I mean, I've been asked this so many times in many of the exhibitions. So the idea is the same technology that you can have in order to levitate the object, it can also provide you a platform that can be levitated and reach the actual platform. So there could be a platform that's totally separated, and then that platform uses the same technology that will allow you to levitate and enter the actual space.
Right, so another question's come in, quite a general one actually for you. What is the best way for an aspiring young architect to get into gravity-defying architecture?
I mean, there's a lot. I mean, you can see with all the literature and the people and the companies that I actually mentioned, they're all doing that. So my advice to you is do research. I mean, look around, see who is doing that, and try to connect with them, try to network with them. I mean, I'm more than happy. I'm open also to discuss this, and so feel free to reach out to me if you want. But the idea is, this is something that it cannot be done by a group of people, but it's a big thing. So a collaboration is always appreciated. So I think for you, if you are a rising new or fresh architect, definitely research is key. Understand really how things are, where are the current technologies. Because as I mentioned, it's not about one topic, it's not about one thing. They all come together so that to generate that outcome. So it could be from the design perspective, or from engineering perspective, or from technology perspective, and so forth.
All right. So someone's asked, what about a fail-safe system?
Sorry, can you repeat that?
Someone has a question regarding what about a fail-safe system?
A fail-safe
system. I assume this is in regards to, if the building fails at some point of time, is there a backup to that? That's what I assume this means.
Okay, so if this is what they mean, then definitely there should be, like any other backup system. Like if you have anything that requires backup system, because also you have to think, how are we generating this energy to actually generate that thing? So it could be the source of energy that you're using, which I would prefer to be a green source, or a source that is, not harmful to the environment. That source, if actually is there and it's permanent, then it's not a big deal. But also if there's an issue where a failure could happen, like any other thing in the world, it should have a backup way, or maybe a system where it can, bring it down or bring it up at a certain time.
Right. Another question that's similar to one you answered. Someone said, very interesting concept. How will we be able to access the architectural space? And actually in brackets have mentioned, are we going to float in it like in movies?
So this is actually, the second part of the question is very interesting, because when I mentioned also the identity of architecture will be questioned. So because we are used to buildings being in one place where we can go and visit that building. But the concept of liberating itself from the ground doesn't really necessarily allowing it to be in one position. Of course, being in one position is as a start, but depending on technologies, depending on plausible elements in the future, maybe architecture changes a little bit the identity, or evolve in a certain direction. So maybe architecture is no more rigid in one place. Maybe it's more of a moving structure, or maybe it's an element that instead of you going to the space will come to you. I mean, of course, this is all up to debate and prediction, but there is a way that depending on what technologies will be, to actually not think of an architecture as the same way that we think of it now. So that identity also might evolve, or maybe a branch out of that identity can become present.
Right. And we have a question from Mariam. Do you think human behavior will have to adapt to these ideas? And how so will the challenges be brought forward?
I think, if you take the pandemic as an example, you could see that the capacity and the amazing ability for us to adapt to changes. I mean, humans have an amazing way of adapting to things. Of course, in this way, as I said, if you look at the installation that has been done of floating spheres, where people experiencing that feeling of being inside a space that is actually suspended in the air, of course that's a different experience. And perhaps with time, if this goes further, we might see more of these, and accordingly human behavior will adapt to that. So I have a big optimistic thing about humans, is that we have a big capacity to adapt to change. And this is not an exception.
Absolutely. And was there any specific reason, for you to create an asymmetrical building? Was it something to do with the spatial phenomena, something to do with technicalities?
I always been I always admire asymmetry myself. And I think it adds an additional challenge because symmetry will automatically is balanced. So when you try to balance something that is asymmetrical, it gives that extra spice or extra challenge where you see the object, like in nature, we don't have really symmetry in nature. So I wanted to emphasize on that. And since the prototypes that I create were at the beginning, they comprises element of nature. And if you see the name of these prototypes, they were the spring, the river, and the waterfall. So they have that aspect of natural aspect. And that's why for me, symmetry was not the best approach to it. And it added that challenge for me. And I think, having an element that is floating in the air that is not symmetrical will show that this is an even more difficult thing to do, but it is doable.
I agree. Very interesting. Another question has come in, which actually crossed my mind as well regarding, MEP services. So the question is, how would there be a constant water supply in the building?
Of course, this is also a question that actually been asked by many in the in the exhibitions. So how will you distribute water? How will you, evacuate water and all of that? Of course, this is, a very legitimate question. The issue is you can look at, for example, the airplanes. The airplanes are vehicles that actually go from one space to another, and they have a system where they also have water distribution and water evacuation. So we could start by something like this. And if we allow the system to float up and down, then it's not a big deal to actually changing it. Of course, more things will evolve and more things will be plausible depending on the technology. The idea is that I want to emphasize on, of course, there are obstacles. Any research has these obstacles, but I don't want these obstacles to deter from the main concept that actually to provide the opportunity of allowing architecture to totally liberate itself from the ground. And I think with time, more solutions will arise depending on the advancement and development in human inventions.
Absolutely. Another question, if the prototype is based on magnetic fields, how would you propose to create a field that will span on Earth and give the idea of free floating?
The issue is a very good question. I used electromagnetic field as one of the technologies, and it's very important to point out, like some has misunderstood that, okay, this is the only thing I'm doing. It is not. As I mentioned, as an architect, we look around for many different things happening, and we try to bring them together and link them in order to generate the invention or the design. So it is not only electromagnetic. So it is, of course, the one that I'm showing uses that technology, but I'm not only using that technology. I'm not only thinking about that technology. So whatever will allow the scale, the scalability of the project, or the capacity to float more, or the capacity to to move maybe. So all of these I'm open to. I'm not only focusing on just one technology. So maybe at this scale and in this prototype, I'm using this is available. But I'm also thinking of other type of technologies, such as the UAV. That could be one of them. That also would allow a stronger element to float. So I would not exclude any.
Mm-hmm. Right. And just, good segue from that. Another question has come in regarding, whether the platform requires a lot of energy resources.
Definitely, everything that we are using and we're living in requires energy. As you can see, everything you use, everything you do. The issue is not about having energy or needing energy. The issue is how you generate that energy. I mean, you can generate it, in a very bad way, and it could be harmful to nature, or you could generate it in a good way, like solar panels. There's many of ways that now you can generate energy other than the conventional one that actually is harmful to nature. Now, of course, I would want to. I mean, if you look at like even solar panels has been used in usually outer space vehicles that they use the solar panel to actually be able to generate energy. And that's why it later on became very well used and known. So I think also the capacity to create a source of energy that is green and at the same time affordable. So when you be able to create an affordable technology, that allow you to use green energy, then I think most of us will revert to that. And this, of course, will not be an exception. So my preference would not be to use harmful source of energy, but of course of green source of energy.
Mm-hmm. Right, and we have a thought that's come in here from Abir. So he says, thank you for the very interesting presentation. There's some constructive criticism, I think, that's come in. So he states, why do we need to have anti-gravity architecture? The Earth is still very vast for erecting architecture. Why do we need to challenge a natural factor?
Actually, I really welcome the debate. I really welcome these questions. These questions are very important because they make us think. And he's right. I mean, that is a legitimate question. You can ask the same question of any ambition or any aspiration that we have as humanity. Even going in the outer space. I mean, why do we need to go in the outer space? I mean, I understand that question, but you have to think that it's not only symbolic and it's not only about the aspiration of doing the impossible, but also there are practical aspects, as I mentioned in the presentation. I mean, in a situation where you have earthquake, in a situation where you have floodings, there are some situations where when you provide the capacity for the architecture to float, then it actually escapes the natural disasters. But I'm not saying I'm doing this because of that. It is one of the benefits. It's not the only benefit. So it could be explained in this way for people who really needs the rational, understanding of why we're doing this. There's also a symbolic aspect of it, a theoretical aspect of it. Even when I mentioned the idea of really questioning or revisiting the idea of the identity of architecture. I mean, that's a theoretical way of thinking about architecture. So these type of, let's say, invention or these type of a way that we do things not in a conventional way will open this conversation and will help us advance and move forward.
Absolutely, and as you rightly said, the only way to move forward is asking questions. I remember learning about Buckminster Fuller's space frames. At the time there was such heavy criticism about it, but look at us now, we're using it on a daily basis.
Yeah, absolutely.
Perfect. So another question has come in. So thank you for the wonderful presentation. What is the practical weight to levitate? For example, would skyscrapers ever be a possibility?
I mean, that's a good one. And I think it will depend, of course, on the material, on the capacity of the technology. But I would not, I would not say no, but also I cannot confirm at the moment. But I think since it's an ongoing research, so the size, the weight, the technology coming together will actually influence and will be the one who will actually give that answer, whether we'll be able to generate as big as a tower or as big as, as a house and so forth.
Mm-hmm. Right, another question. So what sort of energy consumption was required to levitate the prototype? They state that the question relates to sustainability, green energy, etc., and the impact that it might have on our planet.
Oh, sure. I mean, if you know that there are even levitating now trains. I mean, the high speed train. I mean, they are levitating it using, of course, the maglev. They call it maglev. So even the big, very heavy vehicles are being able to use certain technology to levitate. So why not, bigger ones? And as I mentioned, it's not about the use of energy, is the type, the energy we will have to use our whole life. I mean, there's no escape from it. It's how you generate that energy is what will make the difference. So if there's a way where you can harness energy to create an electromagnetic field that will allow that levitation without the harm of nature, then there's no harm in it. On the contrary, it's actually more sustainable and it's better. So for me, even now, if it appears that it is impossible or maybe is not green, I would again say to everyone, it's not about the production of energy, it's how you produce, how you bring that energy into reality, whether you use the good way or the harmful way.
Right. We actually have a comment that's coming from the director of RIBA International, Azlina Bulmer. She states, thank you, Georges, for an amazing lecture, great content, and thoroughly enjoyed it.
Thank you.
Moving to the next question. So someone has asked, how do you gauge the power usage? for gravity-defiant architecture?
The power, sorry? Okay, can you repeat that? I didn't get it.
Yeah, absolutely. So someone says, how do you gauge the power usage for gravity-defiant architecture?
I mean, again, this will relate to technology. This will relate with the type of source that we want to generate energy out of it. So all is depending on, again, these three main elements that I said in the presentation that are, the materiality, the design itself and the form, and of course the technology itself and how you can use that technology in order to, levitate the object.
So another question has come in regarding, the use of floating architecture. They would like to know, if it does not relate to one place, what would you comment on regarding, ownership and city rules when it comes to floating architecture?
A very good question. I can tell you this is part of the debates and the discussions that this type of architecture will make occur. So, for example, talking about real estate, talking about maybe the ownership of certain aerial. Like when you own a certain land, but maybe what about owning, the space above that land? So, of course, this is very important. But until we reach there will definitely be an impact on real estate, an impact on the way we think architecture as being located in one space, and how actually the void above the land, how we can work with. And definitely that is on the table, and that will affect, this aspect.
Right. And would you consider that the technology and design could be used on smaller, singular suburban homes, not just inner city large buildings?
Yes, of course. I mean, the original idea came is when I wanted to create an element, a secluded element where people can escape to actually reconnect with nature, and that's where they originally started. And then the idea of becoming levitated itself physically was to give that symbol that the seclusion from the city within the city is, by making it on a different level than the actual city. And of course, this could be expanded to any part of the world. Again, the idea of thinking architecture even in one location could be even rethought of. Architecture throughout history was always located at a certain, time and space and location, and was never moved. But now, even you have sometimes where they be able to move a certain structure to fix, the land and then bring it back. There's a lot of things and invention that we are creating that is allowing. I'm not saying about kinetic architecture per se, but I'm saying that the plausibility of making something moving or floating and so forth.
Right. And here's another interesting question. I know you're not a health expert, but this question relates to that. So WebHub states that currently people are demagnetizing their living spaces because it harms their bodies. So I think they mean moving away from keeping electronics near them. But if people start living inside it, would it affect our body? Do you have any thoughts on that?
Actually, that's a very good question, and of course, more research is required once this become more of a reality. But you have to understand the way that the design is made is kind of similar to the base isolation system, which means that from the ground and below, and from the ground and above, until you reach the platform that is levitated, this is where the actual force is happening. But within the object itself, you don't feel anything. There's nothing that you would have, no electromagnetic, nothing. And this is, of course, if we're using only electromagnetic field. I mean, if you use another technology, this could lead to something else. But if in this situation with this technology, it's the area that is in between that might have that aspect, but not when you are inside the building. And of course, for me, my aspiration is not to stay with one technology, but maybe incorporate many at the same time, or incorporate the most successful one or the strongest one, and so forth. So I really don't exclude or include any of the technologies. And I would say, from a health perspective, of course, we need more research on that. And once this is done, we could more try and see the effect on it.
Right, of course. Another question. So how can GDA be applied to industrial architecture?
Well, you can say like any other architecture can do that. I mean, and GDA is not an exception. I would say I mentioned about the different future plausible cities, and since the Industrial Revolution, things has changed immensely. And I think now with the latest technologies, also this change will happen. And the way that we think about, even industrial architecture will change. Architecture itself and the identity of it will change.
Mm, absolutely. And in cases of natural disasters like flooding or earthquakes, someone has questioned whether the platform that's the source of the levitation, would that be expected too?
Can you please repeat that? I did not hear it very well.
No, not a problem. So in cases of natural disasters like flooding or earthquakes, wouldn't the platform that is the source of levitation be affected as well?
No, I mean, it's very similar if you think of it of the Japanese famous base isolation system is usually when they isolate the actual structure from the ground. So if the ground moves, then the structure is isolated, and in this way it is not really affected by the movement of the earth. So when you totally separate it, then there is no affection in this way. So it will definitely not being affected by earthquakes.
Right. And how do you think this will affect the selling of plots and governmental zoning?
Yes, that's also a very important question. And I think this would create an impact on that. And actually, it's an opportunity. I mean, it could not be seen as something that is negative, because then there's an opportunity of perceiving, as I said, the void above the platform, the void above the plot. So you could think of a different way, maybe a three-dimensional way of, because we're used to build on the ground, correct? So we used to build on a flat, or maybe, a certain form of a land, but it used to be almost two-dimensional. But the moment you have the capacity to float, then you can think of a totally different way of creating maybe a grid and three-dimensional grid rather than a plot. So it's a volume, and this is all open to debate, and this will require people who are specialized in the real estate and all of that to say about what opportunities can arise from such a different way of creating architecture.
Right, and perhaps the last question before we close today's session, an open-ended one for you. What challenges excites you the most about gravity-defined architecture?
For me is what to do to make it happen. I think that's the biggest challenge that I would like as an aspiration, and of course this comes with hard work and comes with resilience and determination. But I would like to think that in my lifetime I would be able to see at least one architectural element that I can construct and I can make in real, and hear and feel and see the experience of people doing it. So I think that's the biggest challenge that in my lifetime I'll be able to accomplish that. And of course, this all will depend on funding, depend on support on so many levels, as I mentioned in the presentation. So, but that is probably the biggest challenge for me, is to really make it happen, scale 1-to-1, so for people to be able to experience it.
Right. Well, that's a really great answer actually for us to close today's session. I'm sure you will be able to see some part of it within this lifetime. All right, if there are no further questions, I think we can close today's session. A huge thank you, Georges, personally for taking time out of your day, midweek to join us in launching the RIBA Gulf Live Lunch Talks for 2021. And also thank you to everyone for joining us on your lunch break from within the Gulf, as well as our audience from all over the world. Truly, what a wonderful way of inaugurating the RIBA Gulf Live Lunch Talk. So thank you, Georges.
Thank you so much for providing this opportunity, and have a good day to all, or good evening.
And just a reminder to all of you, if you would like to join the RIBA, please email the contacts listed in the chat bar alongside, or just send in your email address in the chat bar now, and we'd be glad to complete your membership for you. We will be hosting the next session of the series next month towards the end of February, so do keep a lookout for the details of the next session as well. Thank you, everyone.